Okay, outline, kita ada intro and they have we'll talk about the environmental requirement for chemical plant or any other development pun. Kita talk about the environmental impact assessment, wastewater treatment, air emission, and scheduled waste. Next. Okay. Chemical plant, and you are maybe chemical engineers, you should know about this, especially any chemical plant design will have to comply with all environmental requirements. And sometimes beware, financially, the cost to comply with environmental requirements sometimes will be higher than production cost. Maknanya treatment and so on. You have to, people will think that environmental requirement only need very little money. No, be careful about that. Karena when we deal with hazardous chemical and so on, to comply with environmental requirement, they will control air pollution, water pollution, apa semua tu. Sometimes dia punya plan design tu, the cost of control tu lebih mahal daripada production cost. Next. Okay. So basically, the law that make the environmental requirement Malaysia start in the legal side of it started in 1974. During that period, kita punya chemical plant pun very little. Actually, the one that cost the what I call it, the parliament to pass the law EQA adalah kerana pencemaran, pollution caused by mostly from palm oil mill and also rubber mills masa tu. That is the started of the whole thing. And that the first what I call regulation we have, basically specific for the two industries, daripada rubber industries and also daripada palm oil mill, specifically to that. And from there on, there are so many regulation promulgated from there, you know, so banyak juga the amendment done to the Environmental Quality Act. So basically that as of now ada 19 regulation, 2 rule and 16 orders, berlainan semua tu keperluan tu. Alright, and basically that's the act that created the Department of Environment. So you must remember that environmental what I call DOE, which basically created to take care of a specific environmental requirement. I mean, because of the so people tend to what I call it, to misconstrue, misunderstood about the Department of Environment. Some people call it called DOE, Department of Everything. Yang tak ada, there's no such thing. Because they think that DOE, everything bawah isu-isu alam sekitar mesti di bawah DOE. No, dia hanya apa yang diletak di bawah EQA 1970, Akta Kualiti Alam Sekeliling 1974. That's the only what I call it, law that DOE try to what I call it, enforce. Lain pada tu banyak department lain yang involved. Kalau isu on environment, but lebih for forestry, then you have forestry department, you have fisheries department, and so on. So DOE, walaupun orang kata dia Department of Everything, dia have a limited scope. Next. Okay. Well, basically you can still buy the hard copy. Di banyak Tiani bookstore, Environmental Quality Act 1974, Act 127, and all the regulation. But at the same time, all the act and the regulation are available on the DOE website. You can print, you go and you can download it, you can read that, and so on. Okay, so jangan kata tak ada duit nak beli buku ke apa semua. It's everything sekarang senang, everything available. Alright. So next. Okay. Okay, yang basically you have to consider that kalau katalah buat process plant, chemical plant, or something similar, the first part you have to consider is the EIA. the environmental impact assessment. You have I think most plant will need this. Maknanya kalau sebelum nak buat tu, you kena buat EIA before you're allowed to build your plant. Lepas tu ada consideration air quality, water quality, itu standard lah, schedule waste. If you have schedule waste, then you have to make sure that you dispose of your scheduled waste accordingly. Next. Okay. Environmental context the EIA, basically Environmental Quality Prescribed Premise Order 2215. Basically, project initiator maknanya the company that want to start build the plant have to carry out the EIA before starting out. And tak boleh kata dulu maybe in the beginning boleh buat dulu baru buat EIA. No more. Before you even break ground, buat anything apa semua, basically you need to do the EIA first. So basically dia terbahagi kepada dua, 20 project activities under the first schedule and 17 project under second schedule. The old name for this first schedule tu kita panggil preliminary EIA, prelim EIA, and then second schedule is what we call the detailed EIA, DEIA. Basically most chemical plant memang perlu EIA approval, tetapi depend on the kind of chemical you produce, the kind of process you do. So first schedule approval by the state DOE office, usually the smaller one and so on. Tapi still you have to do the study lah. You have to hire a consultant to do that. But it's a very less rigorous requirement when you have first schedule to fulfill. Maknanya you don't have macam second schedule, the detailed EIA is this basically managed by the OEHQ, bahagian EIA dan penilaian basically more rigorous, basically more expert have to look through it. Usually second schedule it is necessary because of the what you call it, the requirement are more stringent and so on. All right. So next. Okay. Design aspect to be considered. First, siting. Kat mana nak letak? The proposed project site. Basically, memang you kena adalah semua. You have the national physical plan yang memang Malaysia have physical plan. Dia ada peta dah. Sini boleh buat kat mana. Lepas tu at the same time we have to follow the state structure plan, and the more specific is the district local plan. Mana kalau kawasan bandar Allostatic, apa dia punya plan. Mana-mana tempat-tempat tertentu boleh buat certain kilang, tempat tertentu tak boleh. Tapi this one always controversial lah. This national physical plan, structure plan. Pasal apa? Do you know why I said it? Because banyak tak ikut. Itu reality mana mula buat macam ni, lepas tu berbelit-belit nak buat benda lain. Ini something that saya sebagai the one that have been through all the thick and thin of the environmental thing. Usually national physical plan, state structure plan, district plan ada, tetapi nak ikut tu yang problematik tu, yang nak ikut 100%. Adalah they bend the rule and so on. Kadang-kadang ikut tu. Itu yang kadang-kadang sedih tu. Okay. Approve guideline for siting and zoning memang ada. Ini pun you boleh download from the tu. Even the EIA itself, the guideline how to carry out EIA study pun ada dalam website. Semua tu free, boleh dapat semua. Alright. Next. Siting lagi. Design expect to be for EIA for siting. Always location. Alright. Tempat tu macam mana? Apa ada dekat situ? Industri lain, rumah orang dan sebagainya. So the existing environment of the site shall not contradict with the nature of the proposed project. Maknanya tak boleh. Apa yang ada tak boleh konflik. Macam satu cement plant, because of the location of a very good Ya, somebody ada apa? Sorry. Whatever it is, the existing environment sepatutnya tak in conflict with the proposed project. Umpamanya saya nak sebut the cement plant proposed for in Merapu. I don't know whether any of you have climbed Gunung Tahan. Kalau you have climbed Gunung Tahan, most of the time you naik daripada Merapu. You climb Gunung Tahan, the second entry point usually in Merapu, both in Pahang, satu lagi yang pertama di Kuala Tahan. Tapi dia kata yang the better one is to climb from Merapu and to exit from Kuala Tahan. So I did that with my student masa UTM KL dulu tahun 1993. I don't know how old you masa tu. 1993. Okay. That one the thing is kat Merapu tu they have hills, banyak formation yang good limestone, 90% pure limestone, so very good for making cement. But because the location basically is next to tourist area, what I call it, ecotourism area. Saya kata it's contradictory. So basically the villagers are against it, against the project. It's a good project, but it is not good for the location. So they fought the proposal. EIA pun masuk, people say against it. Lama-lama kita lawan dia in 2012. It was basically rejected, and they ran over to Kelantan after that. That's another story. Next. Okay. So kalau you masuk district local plan, dia very detailed one. Dia ada tanda elok-elok dah. Guna tanah sedia ada, and in the future dia tanda sekali. Perumahan, commercial, industry, recreational area, agriculture, and so on. Dia tanda semua dah. So in the future, takkan kita nak letak satu chemical plant with dangerous chemical next to a housing area. You don't do that, basically. Okay. Next. Kalau katalah for state such as Selangor, they have their own they have their own structure plan kat mana. Forested area dia kita letak kat mana. Industries dia letak kat mana. Alright. Itu sometimes what happen, dia ada konflik kerana tiba-tiba major investment coming in with not million but billion of ringgit, and they want to be built in area that very sensitive. Timbul kerajaan negeri pun mula itulah, mula orang kata hilang pertimbangan lah, tak kira apabila billion coming in, they forget dia punya responsibility. Next. Berarti itu kejap. Question. Sengap langsung. Question. Baik, tanya.
You can ask any question to Prof.
Pasal the introduction and also basically the EIA or the legal, the illegal aspect, and also the EIA. If you have any question. Tak faham. Tak ada.
Okay, mungkin orang
tak apa, kalau tak ada tak apa. Saya at the end of the slide tu saya ada my WhatsApp apa semua, they can ask later. Tetapi kalau nak tanya sekarang lah. Because kalau dah kita masuk subjek lain, takut terlupa soalan dan sebagainya.
Alright.
Anything? Tak ada. Okay. Tak apa. Wastewater. Kita tahulah wastewater should be treated prior to discharge. Belum. This one of the thing kita panggil, this one is point source. Point source maknanya dalam wastewater punya terminology, and also pollution terminology, we call, kalau wastewater, kalau kilang from a factory coming, they have a discharge point, we call it point source. Bukan tunjuk tau, bukan tunjuk. Maknanya point source maknanya ada lokasi dia. Kalau from discharge point daripada parit, kita boleh tanda dia. Macam within the law, within AQA, dalam undang-undang alam sekitar, dia dah sebut. Last final discharge, mesti ada tanda. Final discharge, dia kena sebut. Kerana tempat tu, where both the monitoring by the factory should be done. Dia punya sama ada boleh comply with the law or not. Even DOE datang pun dia boleh sample from that location. And tempat tu selalunya mesti easily accessible. Jangan buat tempat yang penuh dengan ular dan sebagainya. Itu tak boleh tu. Semua itu. So basically point source is relative to non-point source. Non-point source maknanya cannot be measured at one point, always shifting. Okay. Kalau contoh daripada non-point source macam satu bukit, you basically develop into what you call it, into housing estate. If you want to sample for suspended solid after rainfall, you sample kat mana? Tak ada parit lagi masa tu. So, you don't know where. Itu basically non-point source pollution. Kalau katalah discharge from point source, you boleh pergi ambil kat situ at any time. You boleh pergi ambil from that location. And basically, wastewater shall meet with discharge standard limit. Nah, location tu ikut requirement lokasi tersebut. Semua dah ambil pollution control kan? Dr. Ilyas? Dah ambil? Sudah.
Semua dah ambil.
Okay.
Pollution control.
So, siapa ingat standard A dengan standard B? You can tulis, boleh nampak tu. Anybody remember? Jangan cengkerik keluar pula. Kerik. Ya. Siapa still remember what is standard A, what is standard B? Saya tanya you balik. Sengap semua.
Senyap semua ni.
Jangan tak tahu. Itu one of the thing you learn. Kalau dalam kelas saya saja pollution control standard A, standard B jangan lupa. BOD jangan lupa macam mana treatment. Macam mana you measure dia. Itu saya make sure you tahu tu. Ingat tak standard A, standard B? Itu kata tu shall meet discharge standard limit. Maknanya kalau standard A tu downstream, kalau kilang you upstream of water intake. Maknanya downstream orang ambil air itu untuk minum. Maknanya untuk treatment. Maknanya kalau di Johor ni, syarikat air Johor. Oh, sorry, Amzad, nama itu English. Sorry, Amzad, you are not Malaysian, are you? Amzad tanya, dia kata English. Okay. We have to consider standard A as the limit whereby you have water intake for what I call it, water treatment plant downstream of your plant. That's why I say location. Don't make the mistake of building or even trying to build a plant upstream of water intake, because your requirement will be more strict. And if you pollute the water, you're in trouble. So standard A. So anything downstream is standard B. You must remember that. Standard A and standard B. All right? Don't forget about that. Actually, within the Environmental Quality Act 1974, they already list, lama punya list, old list of all the location and the punya GPS location of the water intake in the whole Malaysia. But as far as I'm concerned, I think it's not updated. New location that are not listed in there. All right. So regulation as referred to the EQA adalah as listed. Environmental Quality Act sewage regulation. That's basically for human sewerage. Environmental quality control of pollution from solid waste station and landfill. That means for the control of pollution from anything related to solid waste disposal, tempat buangan sampah, sanitary. And also one of the latest one, environmental quality industrial effluent, very specific to industrial effluent. Next. Wastewater treatment design. Okay. basically, when you design a wastewater treatment, you must select treatment mechanism and technology related to your pollutant. All right. So if you are producing something that high in organics, you have to design your treatment that will remove the organic matter. If you are saying producing food industry, you have to treating mechanism that try to remove basically the BOD, the COD, mostly the BOD and the ammonium nitrogen and so on. All right. Then don't design something that's not needed. Ini one of the big mistake kalau you are an engineer try to design. So the wastewater treatment must be selected to ensure that they can the treatment itself can treat the pollutants that in your wastewater, the raw wastewater. And in such a design, it says what at the end when the discharge it can comply with the law. Okay. Sizing. Ini sizing ini kalau if somebody from civil, they understood sangatlah. Bukan saja wastewater treatment, but also in drainage. When you design drainage system, you ever heard of the term 25 years flood, 10 years flood, okay, 50 years flood, 100-year flood. You must design. Don't be too large because anything large costs money. You need no more land for drainage. So basically, if possible, just the right size. If undersized, for wastewater treatment, you are not treating it well. If you're talking about drainage system, if you're undersized, your drain will overflow. Will cause flood. If oversized, tak apa. But if the flood is very high, no problem. But the thing is, it will cost you more money. And you need more land. When you are designing a drainage system within a small, in a town, you have to consider the land use. If say even in Taman University, you have to consider. You basically, if too large, then it will take away the land for the road, for the building, and so on. You have to consider that, because in a city, land is on its premium. All right. So the treatment mechanism and technology depend on type of pollutant. You have to consider that. Chemical plant treatment is different when you have biological in your wastewater. Biological material and more like food waste and so on. You have to consider the two need different kind of treatment. Next. First, if you are thinking about the pollutant, it's usually divided into, basically this is very, very basic lah. Basically, the physical part is the particle, total suspended solid. Anything that's suspended in the water, and that must be considered. Other than that, soluble organic matter, BOD, COD, ammonium nitrogen, and other than that, the one that more hazardous, heavy metal. I hope you remember your chemistry. Why the heavy metal comes into being? Why they call it heavy? Anybody? Any volunteer? Why it calls heavy metal? Is it because it's physically heavy? Dr. Ilyas tahu tak? Volunteer? Dr. Ilyas lah.
Volunteer from students.
Kalau Dr. Ilyas tak tahu, berat lah if you don't know the answer. Basically, heavy metal, if you look at your periodic table, is the one that have a higher number. That's all. Basically, that too. But doesn't make this heavy lah. Dia basically it is the position in the periodic table is on the number is bigger. Tapi as you know, heavy metal as of the list on the top of my head, aku kata things like mercury, lead, what I call it, cadmium, zinc, and so on. Those are heavy metal. Basically, those are toxic when even in small amount. Tapi you must remember, jangan kata apa tu everything nama all this very bad for you. You be very very interesting. Like zinc. Zinc high amount bad for you, but zinc in your vitamin is good for you. Only. So you must know. Everybody yang kata it is zinc is all bad. No, you must remember that, because zinc is only something that you have even within your drinking, your what you call your pills, your vitamin that you take every day. If you do that, basically, all right. So basically, it depends on the amount. How much is your uptake every day, every year, because your body, in some heavy metal, they have a mechanism of removal, your body, through your kidney and so on. But in high amount, then you'll be in trouble. For example, if you are lead, we know that lead, if the uptake is high among infant and small children, will affect their learning process and so on. All right. So you have to consider that's why heavy metal is critical. And as of organic matter, as you know, high amount of BOD, COD will remove oxygen, especially oxygen in the what I call it, in the water. That will remove oxygen, dissolve oxygen in the water, that can kill fish and so on. While ammonium nitrogen will what I call it, will interfere with water treatment system, karena it combine with chlorine. So benda-benda ni we just want to make it what I call the river just look nice. There are a lot of impact on the people and environment as related to the wastewater. Next.
Prof, ada orang jawab ni.
Apa tu?
Prof, Dr. ni Muhammad Hafiz. Any metallic chemical element that has a relatively and toxic or poisonous at low concentration.
Yeah, betul tu. Good. Ada dia baca somewhere ke tu. That's good. Right? Heavy metal. So we must consider heavy metal. If you have heavy metal problem, if you design a wastewater, if you design a plant, other heavy metal, you have to consider that very, very carefully how the treatment. And that's why also you must be downstream of any water intake. That's one of the problem in designing what I call it, sanitary landfill. Right? As you look at what happened in Malaysia, basically, when you talk about sanitary landfill, when you have leachate coming out, which is very high in organic matter, very high in COD and ammonium nitrogen and heavy metal, you cannot cite upstream water intake. Sepatutnya. Tapi the problem is sanitary landfill use a lot of land. Where can you put it then? Jadi they one of the what I call it, the hard part of designing and citing the landfill. Very hard to find a location whereby downstream doesn't have water intake. If you are in Selangor, if you say, Ulu Selangor, you want to put treatment, want to build what I call it, a sanitary landfill. Everything dekat bawah, everything downstream, you have water intake. Not one, many water intake for Selangor. Sungai Selangor downstream have like other than one in Rasa, you have 4 treatment plant near Batang Berjuntai. Basically. And then if you have in Sungai Langat, if you are upstream in Kajang or in Semenyih, downstream you have 3 water intake. So that one of the hard part you have to consider. Because now I'm looking into Sungai Prai. It was interestingly, they built the most upstream. They built in Kedah. They built dekat Padang Cina. The name of the location is Padang Cina Sanitary Landfill, Kulim, Kedah. The problem is ada 2 treatment plant in Penang downstream. So very careful about that. And it's even you have to consider the interstate travel of pollutant. All right. So now wastewater treatment mechanism. So basically, for suspended matter, particle in water, first you have to go basically somewhere. This is the same process that you have for basically when you are treating drinking water. You have to remove the suspended matter from the water. From a very murky water, teh tarik water, you have to remove the suspended matter to basically to make it clear water, drinkable water. So you have coagulation, flocculation, sedimentation, filtration. Basically, 4-step process. This is not a single process, but on its own, but a 4-step process. Next. Okay. Basically, coagulation. The colloids or the particle tend to re-eject each other. They as of in naturally. Basically, the colloids or the suspended matter tend to eject each other, but that means it doesn't clump together. And because of the size of that size is very small, they tend to suspend in the water. That means let us leave the water for 2-3 days. It will settle down. It will, but can we wait for that for drinking water purpose or wastewater? Tak boleh. We have to make sure that we alter the colloid. So from the one that eject, what I call it, basically kicking out each other, now we have to make sure that they adhere to each other. Become what I call it, sticky to each other. So a coagulant is a substance, basically a chemical that is added to the water to accomplish coagulation. Basically, property of coagulant, trivalent cation, non-toxic, and insoluble in natural pH. Usually that's the one that the best one lah. And usually the one that we know of that become standard billion dollar industry in the world is aluminum sulfate. The term shortened down to alum. Alum is the chemical of choice in water treatment and chemical treatment, chemical process treatment as of to remove suspended matter. Next. Coagulation is the first part. After you add the chemical, the coagulation occur. So what I call it, basically after the coagulation, basically you remove the charge, make the eject each other. Basically, it's supposed to flocculate. All right. Flocculation aim to bring particle into contact for them to agglomerate. The things agglomerate and form larger particle, known as flocks. FC kalau usually in water treatment plant, you can see it easily. They flock. From the one that very dispersed, they flock together. And basically, this you use special pedal, we call it, try to mix. It cannot be, this one is very, what I call it, iffy kind of situation. Too fast, it will break up. Too slow, it doesn't clump to each other. So you basically have to know the kind of speed that is needed. They already know how to design this. Basically, the mixing after the coagulation, you masuk flocculation chamber, and they try to make such a speed that will make sure that the flocks, what I call it, become bigger and bigger, and it can be allowed to settle down. Okay, next. Sedimentation. Okay, kita allow it to settle. All right. Sedimentation is physical water treatment process used to settle out suspended matter in water under influence of gravity. Basically, kita bagi dia, we allow it to in the sedimentation tank. What basically the speed is very minimal. Basically, if not, it doesn't settle down. We allow it to. It is basically its size in order to have optimal sedimentation speed. The other, it moves. It doesn't mean it's basically static. It moves, but will allow for the flocks to settle. And if sedimentation speed is too high, most particles will not have sufficient time to settle and will carry out with the treated water. If speed too low, the tank will be excessive size. You cannot buat. If you design such a way that you make it static, then you have to build the tank, sedimentation as excessive size. So that is one also critical. Next. Okay. Settling basically will take away most of the flock tadi. Tetapi there are some basically impurities that does not settle. So after the coagulation, flocculation, and the settling and sedimentation, you still have some minute particle that did not settle. Then you have to consider filtration. This is basically very similar in water treatment plant. Basically, you build your what I call it, your filter design in such a way that they use media, basically inert media using sand, coal, you know, and many other things, even small rocks and so on. Basically a medium that it become a filter, and basically at the same time it is named into basically three, depending on the speed of the loading rate, the flow rate of water applied per unit area of the filter. Usually they have slow sand filter, rapid sand filter, and high rate sand filter. The most common in Malaysia, as far as I know, the rapid sand filter, because slow sand filter, you need to build quite a large what I call it, area, to cost money usually. So basically, most water treatment in like in Johor or in Negeri Sembilan or in Selangor, I think like Johor, Selangor and Sabah Johor, basically they build filters using rapid sand filter. People have knowledge mostly in that. Next. So basically that is the basic design. Yeah, I don't know whether you can see this. Basically wastewater storage tank apa semua. Basically dia turun. Basically tengok the next photo. This is more of a rapid shelter for drinking water treatment. Basically, the water basically overflow here, and you have the media here, and the uptake is down kat bawah tu. That is where the finished water will be what I call received. Next. Okay. That one basically habis pasal the solid material. Then we have to talk about organic matter, soluble one. You cannot see this one. This basically soluble in the water itself. So the simplest and the most common, I think bukan not the simplest, the most common biological treatment for organic matter to remove BOD, COD, and what I call ammonium nitrogen. We have the activated sludge system and trickling filter. I don't know whether you have seen this. I think you have to go inside the plant to see this. Next. Okay, basically activated sludge is a system whereby you use memang any treatment you basically use bacteria or any microorganism mix as a basically for treatment, because that's the one that usually will eat up your organic matter. Some other whatever the food material ka, oil material ka, basically it is a method whereby the biological sludge which have the microorganism will be used to treat the wastewater. At the same time, when it is aerated and so on, it's recycled. All right. So microorganisms are mixed throughout with organic compound under condition to stimulate their growth. Basically, is activated sludge usually you have a lot of aeration, a lot of movement to ensure that the waste, the microorganism is aerated and basically stimulated for growth. The term activated sludge is macam, this is very good. Now we are during the fasting month. Balik tadi. Ni macam ada bergerak ni. Sorry. Can you go back? It moving by itself. Balik kepada tadi. Ish. Okay, sini. Alright. I don't know what happened, Dr. Ilyas. So, basically, I want to use the analogy of what you call it, of fasting in during Ramadan. The recycle wastewater from the basically at the end of the at the end of the system just now, you can see the system just now. It is the activated sludge is recycled. When it first is introduced to the wastewater, they have enough food, but at the end of the line for the activated sludge system, by that time the food is gone. So the term activated means they have not enough food and they are ready to get fed. That's the one that you basically recycle back because they are hungry. Macam kita berpuasa, when we fasting, when the azan maghrib azan come, kita nak makan everything, something like that. That is the analogy whereby the activated sludge, the bacteria, the whatever, the microorganism, not just bacteria but other microorganism in there, maybe fungi and so on, are ready to get fed. That's what the term activated sludge. The sludge, the hungry sludge, microorganism that gonna help in the treatment of wastewater. All right, the microorganism clump together, flocculate to form active mass of microbe. I call that one the active sludge. Tapi the term sebenarnya tu lebih kepada macam a hungry batch of microbes ready to eat. So that one. Okay, next. Okay, this system basically you can see they have written sludge system line. That means you first go sewage in influent, grid chamber to remove the solid. After that, you masuk primary settling tank. Basically, this is to remove all the large solid. And after that, you go into the treatment, aeration tank. Aeration tank basically whereby the activated sludge from the secondary tank is recycled. The hungry bacteria, hungry microorganism, to mix with the aeration tank. And that one, most of the organic matter will be removed. And it will be settled down, and some will be resettled, and whatever the waste solid will be removed to the digester. And some will be basically discharged as effluent. But sorry to say, disinfection is not a requirement in Malaysia. Disinfection, you don't do that. Basically, not a requirement. Next. It is a bigger one. Okay, so you have influent entering from the primary treatment. This is secondary treatment, activated sludge system. So you have the RAS, written activated sludge, the hungry microorganism mixing the aeration tank. That is most of the activity that happened. The mixed liquor settle in the final settling tank. Some will be as a waste, will become waste activated sludge that will be removed, masuk dalam digester or so on, and some will be returned back as activated sludge. That to recycle back into the aeration tank. Okay, next. Di contoh. This is a bigger one, more like activated sludge, more like a some people call activated ditch and so on. But it's still the system still the same. That means only that it's bigger. It goes in its what I call it, in circular way. All right, activated sludge system. This is a very, very large system. Next, trickling filter. All right. The activated sludge system, they employ such a way that the microorganism is suspended in the wastewater. That's different. Trickling filter, the microorganism is attached to material, coarse material. Some use small stone, slag, plastic, wooden material, and so many kind. I think the most popular now using of plastic material. So attached to it, basically the microorganism. The thing is, we must spray. The term trickling is because the method of spraying of the wastewater. Another term used is a attached growth process because of the microorganism is attached to a solid matter. All right, next. Okay. Before it's the same. You have sewage in or wastewater coming in, your grid chamber, primary settling tank for organic matter, and then you have trickling system. And you have basically the trickling term is because they have the old methodology of spreading the wastewater is basically the called Rotary distributor. All right, so basically they spray the wastewater into the material, on the material. Okay, and it is not just one go. Sometimes it have to be recycled many times before it can basically pass down into the secondary settling tank. Okay, next. This is very simple to show a simple trickling filter. You have from the primary treatment, it goes in, the spray head, spray the water down in the media, and basically media partly covered with water, and basically you mix the water, and then basically the bacteria will attack whatever the organic matter that is in the wastewater. All right, next. Trickling filter, basically another photo, basically. Next. This one is like a cross-section cutting. Next. A photo, basically the jet is basically propel the movement of the what I call it, the sprayer. It goes to the side with the speed, with certain speed, so it goes very slowly. It sprays the wastewater on the material. On the material, and you can see the greenish stuff is basically the microorganism on the material. Okay, next. Okay, let's cover two methods of treatment of the dissolved organic matter. Then we go to heavy metal. Heavy metal is not easy to move, to be removed. Basically, because they are basically dissolved in the what I call it, dissolved in the water. And first, you have to consider first before anything else, you have to bring it out of from the solution into become solid. So basically, the methodology is basically precipitation, and not all heavy metals the same. Lain-lain punya tu. Different pH and so on. So you have to control the pH and so on. After it's precipitate, then the same thing will go through. Similar to the one before. Coagulation, flocculation, sedimentation, filtration. All right. Next. Okay. This is the calculation. If you want to consider later, I don't know whether this one you will need this calculation. Basically, for activated sludge system, how as of sizing method. So say you have a system capacity of flow of wastewater at 0.2 meter cube per second. Banyak tu juga tu. Meter cube kali berapa? Kali 1000. Berapa liter? 2000 liter, 200 liter per second. Okay. So FAM punya ratio, basically this one you can calculate your basically your waste matter, the food. You remember from your pollution control, you have to calculate the FAM ratio, and also the ML VSS. Some say tak payah guna, you don't need to just consider MLSS saja, tapi this one Prof Rozaini put MLVSS strictly. And then you also have to need to know the influent BOD, so it's related. Semua this one will influence. So this one influent BOD, the wastewater, the fresh wastewater BOD is about 150 milligram per liter. All right, next. Basically MLVSS, mixed liquor volatile suspended solid. Basically the suspension tadilah yang from kita punya the hungry bacteria punya part after the aeration tank. Itu that is, you kena calculate that one. You boleh measure. Next. From that you can calculate, because basically what like I said before, when we want to design aeration tank, kita must consider don't be too large and don't be too small. So from that you plug in, you can get a volume of the aeration tank at 720 meter cube. Usually you have to consider possible upgrade and so on. So maybe 727 up to maybe 800 meter cube size, the volume have to boleh consider. Don't make it smaller. A little bit bigger is okay. Too big, then it won't be as efficient, the treatment system. Next, air emission. Ini Prof Rozaini punya what I call it basic ilmu. Dia memang study lebih pada air emission and what I call it incineration. Basically kita mesti comply with environmental quality clean air regulation. Okay, next. The one that human will see first. Kalau kata gas and vapor, kalau gas tu is odorless, we have no problem. But if you have vapor, we have problem. People can smell. But usually the first one human will see is particulate. When you build a factory next to a housing area, it is settle on their house, settle on their cars. Every morning they go to their car, they wipe, tengok, tu dia hitam. Or if even for a housewife, your plant, if they didn't remove particulate, will settle on somebody's daily wash. Your laundry. Makcik semua akan melompat. All the grandmothers, all the mothers will be very angry with you. That's why in the beginning, sighting is important. Other than removal, consider if you are the owner of the plant, you don't want to be covered in in the old days is covered in TV3 or RTM is very bad. Pukul 8, 8 o'clock news, it's bad. But nowadays, easy. People can put an FB, take your photos, video, letak kat situ. How do you like your name be dragged on the social media every day? Please consider. Lepas tu at the same time as Muslim, if you are sorry for the non-Muslim, tapi I have to put some values in this. Some of you, if Muslim, you have to consider. If you cause problem to other people, what are you going to get? The sin to the other human being. Be very careful about that. So you don't pollute. If you become a terrorist, Islam doesn't stop you if you become a terrorist. Islam doesn't stop you to become rich. Tapi at the same time, you have to consider taking care of the environment. Make sure that nobody is swearing at you, or somebody is during their dua after prayers to say bad thing about you. This, give you 4-letter word all the time. So please consider that. To be rich is great. You can do a lot of good for society, but at the same time, you have to consider the consequences of polluting. Next. Control particulate. Basically, this is so many methods now, but this is the 4 basic one lah. Cyclone, filters, liquid scrubbers, allostatic precipitation, ESP, all can be used. Depend on the material, the metal, how big is the size, also consideration of the cost and so on. Some more effective than others. But at the same time, some will be more expensive than others. Next. Cyclone. And it's not cyclone related to the hurricane or anything. Cyclone is basically, but the same method. Basically, the cause gas stream entered tangibly, causing it to flow in a spiral pattern. It is designed in such a way, it is sized in such a way that it collide with the wall and will slide down to the bottom. The thing is to collect the bigger particle, and the clean air flows to the top. Okay, next. Now, basically the design. This is one of the basic design. If you go to industrial area, you can see this outside. It cannot be inside because basically, well, kalau inside, if you have the exhaust outside, it's okay. But usually you can see the big one outside. See, reverse flow cyclone, so the clean gas will go out. All right, dirty gas will go here. The dust is collected at the bottom. Okay, so the dust, depending on the chemical content, if it is basically hazardous, then it must be disposed as hazardous matter. If not, it's considered as like ordinary solid waste. Next, filters. This one is basically very similar to your vacuum cleaner. All right, you move the matter, you pass through a cloth bag or any cloth bag or paper bag and so on, accumulate on the cloth, resulting in a clean gas stream. Yang keluar tu is already clean. So filtering performed primarily by dust layer accumulated on the fabric. That means if the one that the fabric if already full, then you have to basically knock it off and put it back or use a new one. Basically, it's most fabric because costly. Usually, it is basically you can remove, put a new one. You first do some treatment to remove the particle, and the old one can be reused. Basically, all right. So basically, maintenance is very critical. If you allow it to be accumulate after a long while, like the same with your vacuum cleaner, if you don't remove a new filter, then the effectiveness of your system will be gone. Next, sama saja, mechanically clean, shaker, baghouse. So the methodology is the baghouse punya method is basically the filter is here. The filter basically is very similar to the vacuum cleaner. So the outlet coming here, so it can be removed depending on the sama dengan yang tadi juga. If you remove the solid, depending on what in there, if it is considered as hazardous waste, then it must be disposed of properly. If it is basically solid matter, then it can be disposed as a regular solid waste. Next. Basically, this is the air to cloth ratio lah. How you basically control the speed of the air. Basically, the three method: baghouse cleaning method, shaking, reverse air, pulse jet. So the air to cloth punya tu lain. So depending on what your what you call it, whatsoever your need, you can choose which one. I think the cost, the cost of each baghouse is different from each other. Ada yang lebih mahal than others. Next, liquid scrubbing. Basically, yang tadi basically dry. The two method before is basically dry system. All right. Principle of this one, liquid scrubbing, is impacting and shape of dust, particular water droplet. You basically try to make sure that the water spray over the particle will pick it up. Maknanya removal by using water droplet with some chemical or whatever. But two types basically yang common: spray chamber scrubber and venturi scrubbers. And efficiency dependent on the relative velocity between a liquid droplet and suspended particulate. Maknanya how good is the droplet in picking up the suspended particle. Okay, next. Contoh venturi. Venturi is more complicated one. Dia spray from atas and dia macam produce some kind of cyclone for the metal, and then the water will pick it up to settle down here. Okay, next. Allostatic precipitation. Basically, can remove certain particle in the form of dry dust or liquid droplet. Applying of the application of electrical force to separate particle from gas mainstream. Guna some kind of electrical force. All right. Basically, passing particle acquire a charge, then attracted to and collected on oppositely charged plate. Dia tukarlah positive, negative, and so on, and clean gas flow through the ESP. I think this one is more effective, tapi a little bit more costly than others. Next. This is a contoh. From the design, you can see it's basically will take will need more financial cost here. Next. Gas and vapor control. Basically, tadi we talking about solid. Now absorption is absorption, incineration, basically for gas and vapor control system. For gases, that's can cause pollution to the air, and then possibly causing problem to the outside environment. Okay, basically absorption, AB, transfer to liquid. Absorption, transfer to solid. That's the word. You must remember the two terms. Incineration, basically destruction of the gas by high temperature. Next. Absorption, basically to liquid. Diffusion process for molecular transfer from gas to solid due to concentration gradient. Removal of pollutant gas involve 3 steps. Pertama, diffusion of the pollutant to the surface of the liquid and transfer across the gas liquid interface, and basically diffusion of the dissolved gas away from the interface into the liquid. The three process. All right. Next. Spray chamber juga. Dia tadi kita spray chamber remove yang tadi one or two method tadi to remove the solid. Now is basically gonna spray chamber, chemical spray chamber to remove the gas and vapors. Next. Okay, the few other treatment system as of to remove this is a different kind of different design, basically. Plate tower, gunakan plate. This one kita pack tower, dia guna basically material here, special material. Shell ni maknanya basically organic matter lah, yang daripada what you call it, shellfish, daripada kerang and so on, to be used. Alright, next. Adsorption to solid. The capture and retention of a component from gas phase by total surface for adsorbing solid. Saturated absorbent regenerating by contacting with low pressure steam, decanting or distillation. Used to concentrate 30 to 50 poles, concentrate or store contaminant until they are recovered or destroyed in the most common way. Basically, adsorption is to concentrate the what you call it, the liquid, store contaminant until they are recovered or destroyed in the most economical manner. Maknanya it's not single solution. Maknanya this is tend to be more of to concentrate, adsorption. Next. Okay. Absorption cycle, desorption cycle, dia ulang balik. Maknanya they use the solid, and after that they desorption and can be reused the material again. Next. Combustion. Ni Prof Rozaini punya main study area. Actually using high temperature gas phase oxidation, ultimate goal to oxidize organic compound to water and CO2. Not so nice here, CO2. I think people talking about what you call it, carbon dioxide is talking about global warming. So kalau if it is removed as gas, it is not 100% a solution. Water okay, but carbon dioxide is something we have to consider. Maybe it should be what you call it, absorb into carbon dioxide into certain thing or convert into something else of useful. But if you discharge into the air, then that will add into the loading of another of those greenhouse gas, CO2. Used to control odors, reduce opacity of plume, and reduce emission of reactive hydrocarbon. Main advantage, I don't know what it come out as square, I'm not sure here. Advantage is very high efficiency, helps saving length of time and better, I think very high efficiency. All right. Next. Example of the design used for the treatment. Okay. Next. This sizing. Case study determine the required back area for mechanical shaker back house. Tadi dah lama tadi after tadi. Basically determine the required back area for mechanical shaker back house for a gas flow rate of 30 meter cube per second. Dia ada, I think just plug in only. You have basically the rate of 30 meter cube of gas per second, and basically you can calculate the recommended air to cloth ratio is at 0.015 meter per second. And the solution is we need sizing of the back filter is dia punya size of surface area of 2000 meter cube, surface area of the filter system. Next. Schedule waste. Schedule waste to the easy way to say about hazardous waste. Schedule waste, that means it cannot be lumped together with cannot be disposed of like ordinary solid waste or discharged as wastewater. Cannot. It must be treated very specifically. Schedule waste, any waste falling within the categories waste list in the first schedule of the environmental quality schedule waste regulation. You can check that out. Dia ada dah, all the list. Basically, management of schedule waste comply to the procedure outlined by DOE. Used to be in the past only one disposal facility, yang duan dekat Bukit Pelanduk in Negeri Sembilan. And in such way that it's managed in such way that you have only what I call it licensed company that can basically collect your waste, the one you say, okay, this is solid waste, I want it to be removed. And then there's a company like in Johor, they have used to be only 2 companies that can collect your facility, your factory, then they'll transport it to Bukit Pelanduk to be disposed of, whether incineration or as a direct disposal. But it is basically very expensive process. So now there are many other methods as of try to reduce the waste because of the basically in the past monopoly by the quality alam. I don't know which company control it now. I lupa. I think one of the UMNO companies. I forgot about it. But the thing is, because so expensive, it become basically created an illegal activity or industry of disposing illegally. That's very bad when it comes to that, because basically all open areas, all time of the day, some what I call it run by night kind of company will collect your hazardous waste and dispose the waste improperly, and then can pollute the drinking water, can pollute the air, and so on. Basically, this one, if your company do not give the job to the right license or company of disposing it, you're going to have this trouble. They throw it somewhere, suddenly the logo of your factory is there and you'll be prosecuted too. So be careful about that. Next. The related regulation, so all the related one, environmental quality schedule waste regulation 2005, environmental quality prescribed permits, all do. And from the earliest one is 1989, but the latest one pun ada very specific what I call amended regulation for schedule waste. All right, next. But like any waste, schedule waste shall be treated prior to disposal. So treatment option, you can basically the method is you can 100% if that possible on-site treatment if you can neutralize and so on. But some if you do the on-site treatment, if still have to do send to quality alarm, then you have to do it. But the thing is, sometimes it's better to reduce the volume. They charge the volume, they charge the freight to carry the hazardous waste from your your location to quality alam and so on, that will cost you more. So if you can reduce on-site treatment from certain large volume to a small volume, it will save your company money. And so off-site treatment is basically any site that away from away from your plant. You can do it, but must be, the thing is, make sure it is a designated licensed facility, not an illegal one. Ada orang, there are people being still be prosecuted for doing this, because they got caught doing illegal off-site treatment. Next. Well, treatment technology is basically physical treatment. If the solid, so chemical treatment to make sure that you neutralize it. If they have organic matter and so on, biological treatment. But last but not least, incineration. Basically, that we remove most of the things. But in the long run, even if you incinerate, it doesn't just went to the air 100%. There's some solid left. So that one, even if you incinerate, you still have to dispose at a designated facility, macam di quality alam. That one you still have to pay. Next. Okay, physical treatment, this is all too. It does not detoxify but concentrate waste for further treatment or recovery. So you can do carbon adsorption, you can carry out distillation, ion exchange, reverse osmosis, solvent extraction, and so on. Next. You see, carbon absorption is a mass transfer process in which gas, vapor, or chemical in solution are held to a solid by intermolecular force, basically. So you can use so many different, many research in the past, even the present, been done for the kind of solid absorbent that can be used. Activated carbon is another one. Molecular sieve, silica gel, activated alumina. Alumina is an oxide of aluminum. Next. Distillation. Basically, you can, if you can understand distillation, water distillation, you understand this one. Separation of more volatile material from less volatile material by process of vaporization and condensation. Kalau katalah water distillation, you boil the water goes and the gas, it remove the solid in the bottom. But after that, it go through condensation process, it become liquid again. See, the larger the favor pressure difference, the more efficient the separation process by distillation. Tapi, as you know, distillation will need energy, example electric or using gas and so on. Next. Ion exchange, metal and ionized organic chemical can be recovered by ion exchange. This one, ini bawah ni saya tambah pada Prof Zaini tu, dia tak sebut tu. Basically, ion to be removed pass through a bed of resin. Recovery of precious metal. This become a major industry, especially for precious metal as gold, uranium and so on, whatever some other heavy metal yang bukan heavy metal, but usually precious metal you want to recover. So this one become ion exchange is a choice method. Next. Reverse osmosis, basically. Reverse osmosis is basically you use some kind of energy to pass through semi-permanent from a concentrated medium to less concentrated medium. Basically, this is the method used for what I call it in water filtration, especially at your home, your COWE, basically COWE and other water filter that people put in their house now, basically use reverse osmosis method. Next. Now, okay, this is the osmotic flow, how you set it up, semi-permeable membrane in between, basically. You need some kind of pressure, energy to remove it. Karena in natural osmosis, usually the other way happen, isn't it? In regular osmosis, the one that less concentrated moving to the more concentrated salt solution. But the thing is, you reverse the process by putting pressure. You need energy to remove the salt solution, remove to the pure water. Basically, this is the method that being used for desalination of what you call it, seawater into drinking water. The thing is, it is expensive. That's why still always usually this is the desalination process using reverse osmosis is usually the last choice for water production, and it's very expensive. Okay, next. Solvent extraction, liquid extraction, and liquid extraction. Contaminant migrate from the wastewater into the solvent. Basically, you have used this before. I don't know which lab use the method. Basically, you use like especially for recovery of, and it is talking about contaminant, but usually solvent extraction is used in especially for extraction of fragrance from flowers. That's been used. Basically, try to extract from flowers, from roses, from kenanga, and so on. You try to extract. Usually, you use something like liquid extraction, using alcohol or something like that. Next, chemical treatment. Basically, this one it's not a final solution, but convert the waste to another form which are less hazardous than the original material. So you do neutralization, something like pH. You basically from pH 3 you try to neutralize to pH 7, 6, 7, 8, something like that. You oxidize the metal. You also neutralize the thing. Precipitation and also reduction. Both oxidation reaction, the related process. Either you do oxidation or reduction. Both are chemical treatment. Next, neutralization. Basically the law of mass balance to bring the waste to acceptable pH. You guna lah apa-apa dah necessary. Basically, if acidic, you put in some what I call oxide or something that will increase lime and so on to try to increase the pH. Next, oxidation. Basically, the example oxidation. The cyanide molecule. Basically, cyanide is one of the hazardous material. Basically, the molecule cyanide can be destroyed by oxidation. Very specific one. Electrolytic oxidation carried out by anaerobic electrolysis in high temperature, wet air oxidation, Zimmermann process. So basically, this part of the oxidation process, and oxidized by oxygen at sufficient temperature and pressure. And as long as you remove by oxidation any method, basically it is a lot cheaper than bringing it to quality alam. Next. Precipitation, removal of metal from plating, rinse water. Basically, application of solubility product principle, removal of metal plating, rinse water. This one, especially for the electronic industry and so on. All right. Next. Reduction, other than basically oxidation, you can do reduction. Some metal have to be reduced before it can be precipitation. Hexavalent chromium is a plating solution, must be reduced to a trivalent chromium. You must remember. Anybody have watched apa tu? What I call it? Nama what's the movie? Yang berlakon apa tu, Julia Roberts tu. Dr. Ilyas? Dr. Ilyas, kau lari ke mana dah?
Ada.
Hey, mana ada water Terminator? Mana ada Charlie Angel? Ada kata Charlie Angel? No. Cuba tengok yang movie. You have to watch this movie. I think boleh available on Netflix, I think, or and some other thing. You should watch because some of the environmental punya movie dia sometimes over dramatic. Tapi this one kena tengok the early part of pollution yang study apa ni, the actress is Julia Roberts. Dia basically lawan dengan power giant di in California because they pollute the environment with one of the chromium nya ni. So which one? Next one tanya soalan nanti boleh jawab kemudian. I won't tell you now. Which one is good for you? Which one is bad for you? Hexavalent chromium or trivalent chromium? Maknanya hexa berapa? 6 bukan? Trivalent ni 3. So which one is hazardous, one is not. Nah, itu interesting. Tapi memang Julia Roberts, somebody ada masa cuba cari tak? Julia Roberts movie ada keluar. Nama orang tau. Real nama. It's true story. Alright?
Erin Brockovich
Siapa tu? Ya itulah. Tapi itulah Julia Roberts lebih cantik pada orang sebenarnya. Dia lah Julia Roberts more beautiful than the actual lady dalam the real story itu. Tapi you should watch this movie kerana at the end she got awarded. I think she get more than $1 million US dollar. Dia punya boss bagi kat dia because she did most of the work. Alright. So basically the control reduction maknanya boleh remove hexavalent chromium used to in plating solution must be reduced to trivalent chromium. Next. Biological treatment. Basically certain hazardous waste can be removed by biodegradation, novel microorganism. This is new. This is a new concept. Karena you must imagine something that hazardous. How you make sure that bacteria will grow? And only certain specific bacteria boleh grow. Macam dalam wastewater treatment plant yang organic matter, just ordinary microorganism boleh grow. But this one, when it's hazardous, not high temperature, highly acidic, full of heavy metal, not many microorganism can grow. But people already boleh identify certain microorganism that can grow and remove the hazardous waste. This is new. Okay, next. So, basically sama dengan attached growth system, sama dengan trickling filter. This is quite similar trickling filter. Dia buat dalam media tu, in the media they put attach the specific microorganism and you allow the water, the wastewater that's with the scheduled waste to pass through. Okay, next. Incineration, basically most effective dealing with many waste, reduce in volume and weight, and completely destroy even the most hazardous material. But the thing is, it doesn't remove everything. Maknanya in the end, there's still some solid to be removed. That one must be still must be buried in a very secure landfill, only in quality alam or something similar. All right, next. Okay, rotary kiln incinerator. Many design lah. Many design of rotary kiln incinerator that can be used to incinerate. Rotary kiln, the best thing is move, so it is very effective in distribute the in a large area, so senang, be efficient way of incineration. Okay, I think that cover most of the material. Next. Kalau apa-apa nak contact, boleh contact saya. Kalau nak masuk Facebook, guna Messenger pun boleh. Saya jarang-jarang masuk email sekarang. Tapi kalau cakap ada, saya masuklah. Tapi I think most of the communication can be done by WhatsApp nowadays. So if you have question later, you can come to me. Saya boleh jawab, saya akan jawab. Kalau if I can answer the question, I will do that. If not, I can refer to Prof Zaini or other friend and so on. Thank you very much. Soalan dulu. Kalau ada soalan yang on top of your mind, please do.
Okay, ada soalan ke untuk Prof Dr. Maketab?
So watch the movie Brockovich tu. Many movies kan. Ada satu lagi yang terbaru that only the last few years, Dark Waters, that was menang award. Nanti Dark Waters, that's also environmental punya fight, tapi mostly those story basically in the US lah, on environmental issues related. Okay, any question please? Okay, tengok ni from Pulsik. Allah, banyak pula nak saya kena tengok. Let me tengok the message kat mana nak tengok. Maybe kita you boleh keluar pada apa ni, Presentation. Nanti saya tengok. Alright, mana tengok? Mana message layout. Full screen. Layout.
Ada hal buat ni.
Ada sekejap. Mana tahu ni. Ini tak tahu juga ni. Tadi lain nampak dia punya tu. Let me see. Ini nama orang yang keluar.
Oh.
Let me see. Show all. Okay, participant. Nanti kejap. Share video participant. Soalan chat. Tengok chat. Alright.
Okay, Prof.
Zilhal Wani from Pulsik. Waste to energy. Waste to energy, yes. Anything that the thing is about waste to energy is a method whereby any heat produced especially in the removal of waste is used to produce energy. Maknanya it doesn't waste the energy, macam burn something, the temperature that the heat goes to waste. No. I mean, if say you are burning some palm oil solid waste, then don't just incinerate without any capture of the energy. You remove something like that. Or even if in petroleum industry, you see, if you go to Kerteh, you see the flare. That means the waste gas. Itu waste too. They burn the waste gas and they produce all the pollution, all the CO2 and so on. But if they can use the instead of flaring directly and just wasting the energy, it goes to a boiler. Boiler produce hot water produce steam and produce energy. That is a better way. So that into anything. That means any burning of waste, you use that to produce energy. Capture of the energy from the waste burning. Itu that what I mean by that. Okay, yang pertama. Nurul, pool 7. Okay. Is there any important factor that we need to consider when developing waste centralized system? This is not about, it is not actually about treatment of chemical plant, but it is okay. When you're talking about centralized, you have to consider the weather for one thing, central system, because centralized system usually is more applicable in an area that is less rain, not in Malaysia. Ini kalau US less rain, certain area, desert area, kenapa? Basically, dia combined system. Combined system, that means sewerage system not only combine the rainwater with the what I call sewage, but also industries also discharge into there. Okay, that means everything is treated as centralized treatment system. Centralized collection, centralized treatment. The issue is that you must control the amount and the material that goes into your treatment, because some of the waste coming from industry is not compatible with organic treatment. That's one of the problems. I mean, if you have a chemical that kill bacteria, then you cannot do what you call it combined centralized system. Itu you have to be very careful. Maknanya, and you have to charge each one. Maknanya, from houses you charge. Kalau I discharge into they have a meter or something, how much water we use, or use formula whereby if I use a lot of water, that means I produce a lot of wastewater, they charge you according to your use of water. And if from a factory, then how much wastewater that goes into the centralized system. So banyak consideration consider centralized treatment. Okay, let me see. Siapa dulu ni? Tengok naik atas.
Lukman.
Lawani, Nurul Syahira. Okay, centralized. Lukman. Mana Lukman? Okay. Pool 3. CO2 as now, I think we cannot say CO2 too valuable. Isunya CO2 is basically what you call it, a greenhouse gas emission. You don't want to discharge that. I don't know whether kena check balik on the law on CO2. Memang yang lain-lain tu yang poisonous gas, yang specific gas yang cause can cause direct impact on human punya health tu, this different matter. But CO2, I'm not sure Malaysia do that or not, because in the long run each country must reduce emission of greenhouse gas emission. So CO2 is one of them. So I don't know whether Malaysia are doing that monitoring or not. But as of separation method, memang ada. It's not valuable. It's not issue of valuable. The thing is issue of kita discharging something that's bad for the environment. Okay, so basically in the long run, it must be removed. I'm not sure whether this one the Malaysian government look into it. Karena CO2 as of causing direct human impact is very minimal. Their cost problem. CO, carbon monoxide. CO2 is lebih kepada the impact on the kita punya global punya climate change. That's kena must consider. Okay, Danish. Nice hat. Thank you. Ini saya punya identity ni. Saya pakai, nak tahu kalau nak cari saya kat mana-mana, cari nampak topi tu, itulah saya. Is there a simple centralized the waste gas or just treat it on the site? Centralized waste gas tak ada. Memang in Malaysia memang you have to treat on site. Maknanya depend on what kind of gas, you have to find the method, the right method, and then you apply on the waste gas to on your site. Basically, treatment must be depend on the gas and also the regulation that need to be complied. Next one, Rufong, Pool 2. Sama juga ni. Kalau gas emission, you better treat on site. Dia tak ada katalah sambung for the whole tu apa semua. I don't think so. Karena if you say in Pasir Gudang, if you are in a plant that have discharge certain gas, then it better for you to what I call it, to treat it on site. Some tak ada. Alright? Ada lagi?
Ada lagi.
Mana?
Ain Rushdi.
Ni mana? Rushdi. Okay. Ni bukan Ain Rushdi. Okay. For gaseous emission, for example, emission stream containing CO. Kalau CO, I think better oxidize to CO2. Itulah the problemnya. When you basically oxidize to CO2, you nak remove ke mana? Itu. Kalau kira that is kita punya dilema sekarang. Kalau kita become CO2, is less toxic. If you discharge into the atmosphere, it become the source of carbon emission, the green gas house gas emission. So basically that's still negative. So I don't know, this one kena check balik. Let me check balik dengan Rozaini atau orang lain pasal isu ni. Even boleh tanya orang DOE pun nanti. Ni korang nampak ni kena pakai glasses sikit.
Louis Kaishan.
No, bukan. Masih lagi Ain lagi ni.
Okay.
Tak boleh. CO I don't think you boleh jadi fuel. CO you oxidize, basically you hanya become CO2 saja. Alright. Pool 5, waste gas to convert energy. Can we straight use flue gas to buy turbine then changing to steam then going through the steam turbine? Depend. Kalau you boleh flue gas, boleh go to power turbine right away pun boleh. Tetapi I don't know, ada the issue of the energy transfer macam mana, flue gas to power turbine. Kalau they can do that, why not? Kan? Tetapi kalau you pakai flue gas, kalau you burn pun kena check balik what kind of after the flue gas, what is the emission after that. Maknanya this one flue gas, maknanya from the production you have flue gas. The flue gas you burn it, you must see pula what is the gas that release. Itu kena tahu juga tu. And if you can power the turbine, that's good. Kita boleh change to some kind of electricity that you can use yourself or boleh jual pun. Yang this one Rufong lagi. You nanti you answer yourself. Kalau kata centralized, who gonna to centralize the system? That's the thing. Why is better to treat gas emission on site rather than centralized? Can you centralize? Who's supposed to centralize it? Is it if you are say you have kilang Pasir Gudang, do you basically ask the Pasir Gudang authority to what you call it, build the pipeline and ask them to treat for you? Kalau katalah if all the factory have the same gas emission, tak apa. Tapi you build only gas treatment system for one factory, tak guna lah. So it better for each one to just treat on site. Alright. Okay, pool 7. Jia Ying. May I know that wait. May I know usually how should we treat the organic matter that treat the water after the wastewater treatment? Kalau the organic matter, kalau kita guna what you call it activated sludge and so on, basically it's gone. Basically the wastewater, the dissolved wastewater, BOD, COD, ammonium nitrogen within the water, when you use the bacteria makan semua tu. Basically the what I call it, the microorganism eat up the wastewater tu, the organic matter tu, and it's basically use that as their growth energy for growth. Tapi in the end you will have the solid mass of the material that coming from the what I call digester, from the secondary treatment. Then you have to settle it down. You have to remove that one by digesting. That one also consider waste to energy, because basically when you produce you have the digester, you produce methane. Methane can be used to recycled to be used as a fuel. So that's one thing you saya lupa nak cakap tadi. So bagus, you remind me of that. Maknanya daripada wastewater treatment yang menggunakan organic matter, it become what I call it the sludge still organic. You masuk digester, the digester will produce methane, and which is basically can be used to produce energy. All right. Ya, yang last one apa, Danish Hilman. Sekarang, okay. 2 questions just now. You say we can burn gas. Hang use incinerator is the best way to burn it. I think depend on what kind of gas. You cannot depend on what kind of gas you incinerate and how much energy is produced. I think this one also depend on the size of your plant. How much gas you produce. Kalau katalah it's a very abundant energy source, then you can burn it. I mean, not only you remove the waste, but sama ada daripada what you call it hazardous waste, but at the same time you can get energy from that. Tapi kena tahu dululah. Takkan you nak burn something that's so little. That's not possible. Alright. Ada lagi?
Tengok macam ada lagi student?
Mana?
Kita ada dah.
Dah tambah, I tunggu. No problem. Pukul 4 baru kalau ada soalan. Tapi later you boleh WhatsApp saya akan jawab insyaAllah. Alright. Ini duk tengah design ni, nampak kaya soalan tu very specific, itu dia punya design aja ni. Ada designing now? Doktor?
Yeah.
Are they doing the design now?
Yes.
Patutlah. Soalan tu very specific.
Specific pada ini.
Tahu tu. the issue of centralization is depending on the local authority. Katalah macam dengan sewage. Sewage, everybody, every house, every shop, every facility produce your poo and your pee. Faham P and poo. Number 1 and number 2. You discharge. That mean the system is that you have to have connection to all houses to bring it to a facility where it's treated. That's why it's centralized. The same concept, katalah in Pasir Gudang, all factories all the same, tapi different owners. And it produce a gas that need to be can be collected as a waste to energy punya concept. And then it can be centralized. Tapi kalau if you have only 1 or 2 factory, then maybe it's not economical to do that. That is the concept. Centralization. Alright? Ada lagi? Kita bagi 30 second.
Alright.
Mana tahu ada soalan?
Itulah, mungkin ada yang tengah karang soalan ni.
Tahu. Tulis terus je nak karang. This bukan spelling contest, tulis je. How many student you have now?
Sekarang kelas 160 lebih kurang.
160. 3 batch, 4 batch sekarang. Berapa tu? Berapa dia panggil cohort? Cohort, what do you call it?
Satu. Satu cohort.
Satu cohort, tetapi what you call it? Satu section.
Section
Berapa section? 4 section.
Ada 4 section.
Weh, banyak tu. Wow. Interesting. Dulu kita ada most 3 rasanya. Okay. Ada tak?
Ada lagi student?
Tak apa, dia slowly going to. Tapi one thing yang nak tambah is basically nowadays material is available everywhere. So kalau macam from DOE punya part, if you want anything on regulation, guideline, not only regulation, guideline, semua ada online, free. So basically tak payah katalah you kena go and beli at bookshop and sebagainya apa semua, atau kena pergi cari kat library and so on. Maybe sometimes you have to go to the library, but sometimes most material nowadays easily available. So good luck to you all. Kalau apa-apa boleh email, boleh WhatsApp, boleh call pun kalau perlu. WhatsApp lah senang. Apa-apa boleh share nanti. Dan kalau you boleh hantar WhatsApp, kalau nak tanya orang lain, boleh forward kepada orang-orang berkenaan. Saya kenal ramai consultant yang semua boleh tanya directly. Okay, terima kasih banyak. Assalamualaikum, selamat petang.
Okay, Prof. Ambil gambar.
Terima kasih Datuk. Ambil gambar. Sila.
Alright.
You control macam mana?
Okay, student semua boleh open kamera.
Aku tak open kamera. Open kamera. Semua duk tak nampak kamera ni, duk hiding semua.
Itulah tu. Okay.
Malu kot. Ada orang tak mandi Ada orang tak mandi hari ni lagi. Thank you very much. Good luck dah. Tu semua duk thank you tu. Tu Prof tu orang asli panggil Prof. Prof je, without the P, without the F. Jadi Prof je. P-R-O-P.
Alright, yang lain terus buka kamera.
Buka kamera tu. Dengarlah you punya you punya host. Ambil gambar sikit.
Okey.
Jangan malu-malu.
Okey, 1, 2, 3. Alright.
Share gambar doktor.
Boleh.
Nanti share gambar nanti. Terima kasih banyak everybody. Good luck. Selamat berbuka puasa pada yang berpuasa. Assalamualaikum.
Thank you, Prof.
Salam, Prof. Terima kasih, Prof.
Okay, selamat berbuka puasa. Selamat Hari Raya. Take care. Good luck.
Alright. Buka, Prof. Okay, thank you, student. Nanti boleh tulis report, and then can continue designing the plan. Right. So for this week 4 and week 5 is about the centralized waste facilities. Okay, alright, and then I think that's all for today. Okay, thank you guys. Assalamualaikum warahmatullahi wabarakatuh and goodbye.
Thank you, Doctor.
Okay, welcome.